hand if you know what I'm thinking. Hands up. Hands up. Who knows what I'm thinking? Come on. Don't sit and watch. Do the problem. Let's go, Kevin.
To find the relative maximum, you have to see what happens to f prime with f. So f prime would be positive to negative. Is that right?
You're okay. So f will have a relative max when f goes increase to decrease, which means f prime will be changing positive to negative. So I know I need a sign chart of f prime. How many had their hand raised and knew that? 0.2 for Kevin. We want to talk more about it. Okay, so we can, this is kind of back to Matt's question. We can either try to make a sign chart of this, which would be very, very difficult, or we can see if that 97% rule helps. Let's factor and see if we can get anywhere. So I just want to do one simple step. So raise your mind if you know what I'm going to write next. Hands up. What am I going to write next? I just want to do one simple step. What am I going to write next? Go, Colby. So tell me what to write, Colby.
3. This is 5x to the 4 minus 4x squared.
Who had their hand raised and knew it? Point to Colby. Please.
So my point about like questions like that where you can't back that further, you can't like 5x cubed minus 4x squared minus 1. It feels like
Go ahead, keep going.
the only option you have is just trying to options to see which one actually gives you a 0.
So the trick here, here's a good question, 2 points. The trick here is to recognize that this really fits one of your flashcards right here. It doesn't fit exactly, but it fits close enough. I have a flashcard to remind me that when I see a quadratic I want to factor. What you're seeing on the board doesn't look exactly like this, but it does look close enough because it has this appearance. It's 5x to the 4th.
No, it should be x squared, 5x squared.
Minus 4x squared, right? Minus 1. So this is in textbooks call it quadratic form. So I'm going to try to see if I can factor it.
Okay, here we go today.
So this will equal 3. Okay, everybody look here. All eyes up. Okay, when it comes to factoring, I've seen a lot of people lose points for just simple mistakes. So in this class, like I know you learned a lot of different methods in other classes, but in this class, I would argue heavily that the method I'm about to show you is the best for this class. It's simple, it prevents errors. So here's what you start by saying. Blank times blank will be 5x to the 4th. So that's easy. 5x squared and x squared. The thing most people don't do, which you should start doing, is multiply this out and write it over here. So these two multiply to give me 5x to the 4th. The grader won't care because you've got nice notation going straight down the page and you're just doing scratch work over here. Question? Okay, I was helping someone yesterday and here's exactly what they said. I need to factor this, but I can't remember. Is it the, something multiplies to make this or adds to make this, or is it vice versa? That's the whole problem. No one can ever remember that. Everyone always gets it mixed up. Okay? So let's stop doing that. Like, don't use a method that just causes more mistakes. Please raise your hand if you know. No, back up. No one has any trouble knowing that these two things here will multiply to create that. So skip the middle. Just don't even look at it. What two things multiply to make 1? 1 and 1. Except don't worry about the sign either. That also causes a lot of mistakes. So just don't worry about the sign. Just 1 and 1. Now just keep multiplying. So this times this would be 5x squared. Notice no signs. This would be x squared. This would be 1. Now just figure it out. To get a negative 4x, I need a negative here, and I need a positive here to get negative 4x squared. This is created by multiplying these two. So this one's already positive, so this one has to be negative. This one is created by multiplying these two, so this has to be positive. And sure enough, the final does work as well. So now I've checked my work, I feel confident I can move on. If you don't check your work, you'll make a mistake about 1 out of every 2 problems. Question? We need more help here. Cool. So we have f prime. Now you need to make a sign chart of this. So making a sign chart of f prime. F prime is these 3 factors multiplied together. The factor of 3 is always positive, so that doesn't add. Oh, look how cool this is. Raise your hand if you know what I'm thinking. I look at this and I'm like, oh, they gave me a bonus. Like I'm supposed to figure out what values of x will make this positive, negative, and 0. That's the sign chart. When I see this, I'm feeling like, oh, they were so kind. What do I know about this? Talk to each other. More people should know this. Go, James. Look up. Hey, this is why I'm always telling you, don't get into autopilot mode. Always be thinking as you're working. So I get to here and I'm thinking, okay, I need to make a sign chart, but there's no x that will make this negative. There's not even an x that will make this 0. How many can see it? Point, 2 for Jane. This one here, show me on your hand. 1, 2, 3, 4, 5. How many x's will make this equal 0? Show me. How many values of x will make this 0? One, show me. How many values of x will make this 0? A lot of people are making a very common mistake. Whenever you have a squared term, you often have 2 values. Not always, but often. Okay? Show me again, how many values will make this 0? When you have a squared term, you often have 2 values that will make this 0. Give yourself 2 points. Okay, look. This is always positive, this is always positive. They have no effect on the sign chart. The only thing that has an effect is this factor. So when x is -1, this will be 0. When x is 1, this will also be 0. Raise your hand and answer this. When we make a sign chart, we're making a sign chart for f prime. Is the sign chart showing us the x coordinates, y coordinates, or both of f prime? Hands up. Is the sign chart showing me the x coordinates, y coordinates, or both of f prime? That's what I keep telling you. You can't just do what I do. You've got to know why I'm doing it. What does it mean? What is this all telling you? Does the sign chart show you x coordinates, y coordinates, or both, Josh? Both. Go ahead.
Is the x around the line and then the y positive negative?
Perfect. Here's my x coordinates for f prime. Here's my y coordinates for f prime. How many knew it? 2 points. Okay. So we just check it now. Let's see, if I plugged in a 0, this would be negative. So the relative max is at x equal negative 1.
X squared minus 3.
And
1 for 1 square.
say again.
1 for 1 square root. Like, just because we have
Oh, it's just because the square root of 1 is just 1. Does that make sense? It is the square root, but in this case, it's just easy. Does that answer your question? Anybody else? Please.
I don't get how when we factor, how did we figure out the signs, plus and minus?
So are you okay to hear? Or that's where you had trouble? Factoring. Hold on a second. Were you comfortable with the choice of 5x squared and x squared? Are you comfortable with the choice of 1 and 1? So now all I do is I multiply this out without any positives or negatives. So are you okay to hear? Okay. So now just tell me what plus or minus do I need here and here to make sure I get that? Is that good? Okay. So I need a negative here and I need a positive here. You're okay with that, right? Don't worry, just stay with me. Please look over here again. Look up. Look up. I keep telling everyone you've got to make sure you pay really close attention to the equal sign. Right? Somebody asked a really interesting question the other day. They said, see if you can answer this. They said to me, I know how to factor. I just don't have any clue what it is. Like I don't even know what it means. Like I don't get why you factor. And I had to explain that all you're doing is writing the same thing in a different way. In fact, pretty much all of algebra is just different methods of finding a way to write something differently so it's easier to see. Like right here, if you could look at this and identify, you know, at what x this would change from positive to negative. There's no need to do all this other stuff. It's just that most human beings can't do that. They can't just look at this and go, oh yeah, it's easy. They have to write it differently. So factoring isn't changing anything. It's the same thing, just in a different form. So you've got to make sure that this really is this. That's what we're checking over here. So tell me, Colby, what two things multiplied to make this? Good. That's why we know that has to be negative. What two things multiplied to make this? So that's why we know this has to be positive. Because this multiplied out has got to become this. So then we just check it again to make sure we haven't made a mistake. These two, definitely that works. These two, that works. These two, that works. These two, and this really is this. The whole idea is to make sure that this is the same as this is the same as this. Without the check, I think most people make a mistake about half the time. So, okay. 2 points. Anybody else? Anybody need more discussion on this problem? Cool. We're going to pause for a second. We got to get